Three-part question here today. If for C, find the partial fraction decomposition, then find the antiderivative, and then find the average value. So let's start with the partial fraction decomposition. C is 5 over t squared minus 3t minus 10. Factor that. I think that's t minus 5 and t plus 2. And then set up the partial fractions. A over t minus 5 plus b over t plus 2. It doesn't really matter what order you put the partial fractions in, as long as you keep track of which a and b goes on top of which partial fraction. So we're going to multiply both sides by a common denominator. And on the left side, of course, we have cancellation of both terms, both factors. Now, when I distribute on the right side, something interesting happens. This t minus 5 is going to cancel with this t minus 5, and that's just going to give me that t plus 2 multiplied by a. Now, for the other side of it, when I distribute, that's just going to leave me with t plus 5 multiplied by b. But I think you've all passed algebra, so that's not a big deal. And I think this is minus 5. Okay, next step is to choose values for t that will make this solving easier. And as we saw, the first value we're going to pick is 5, because that makes this second term a 0. So if we set t equals 5, 5 is going to be equal to 7a plus 0b, which tells me that a equals 5 over 7. And if t equals negative 2, I get 5 equals, negative 2 plus 2 is 0, so 0a, plus negative 7b. And that tells me b is equal to negative 5 over 7. Remember that just because these are positive 5 over 7 and negative 5 over 7, that's not a pattern you want to rely on. It's not always going to be positive and negative of the same value. So here's our partial fraction decomposition. 5 over t minus 5t plus 2 is 5/7 over t minus 5 minus 5/7 over t plus 2. Part B, what about the antiderivative? Well, let's find the antiderivative here of c, t, that's what the instructions say. That's going to be equal to the antiderivative of 5 over, what is that, t minus 5, t plus 2 dt. And of course, that's going to be equal to the antiderivative of 5/7 t minus 5 dt minus 5/7 t plus 2 dt. Now the antiderivative here, the denominator is linear in terms of t, and also the derivative of t of the denominator, derivative of t plus t minus 5 is 1, and the derivative of t plus 2 is also 1. So that tells me I don't technically have to use a u substitution, or at least I don't have to be too deliberate about it. Of course, if you wanted to, you could say u is equal to t minus 5 and du equals dt. So we have the integral of 5 over 7 over u du. But I'm going to skip that step and just go right to, this is 5/7 the natural log of t minus 5 minus 5/7 the natural log of t plus 2 plus constant. Of course, you can use properties of logs to turn this into the natural log of t minus 5 over t plus 2 plus constant. The next thing is to find the average value. So let's do our average value. The average value, that's going to be equal to 1 over 1 minus 0, integral from 0 to 1 of ct dt. And that's going to be equal to the integral from 0 to 1 of 5 over t minus 5 t plus 2 dt. And of course, we already figured out what that antiderivative is, so we can just go straight to our antiderivative. That's 5/7 natural log of t minus 5 over t plus 2. And we're going to evaluate that from 0 to 1. Of course, there was a 1 over 1 here, but I neglected to write that for, I think, obvious reasons. Let's substitute. We'll get the 5/7 natural log of negative 4 over 3 minus 5/7 natural log of negative 5 over 2. This is why we have those absolute values. There we go. We got positives. And then now we're going to use properties of logs to combine these two. I'll try and do it slowly. That's 5/7 the natural log of 4/3 over 5/2 because of the subtraction. Now 4/3 divided by 5/2 is 8 over 15. So for our final result, we have our average is equal to 5/7 natural log of 8 over 15.